Okay, we will continue our work with similar figures, but in this video we will focus on similar triangles. So, in number 14 we were given that these two triangles are similar, and we're supposed to find the length of UW. Okay, when they say triangle SUW, they're talking about the following triangle. Alright, it's the big triangle, SUW. Now, when they say that's similar to triangle TUV, they're talking about the smaller triangle. Alright, and there's the smaller triangle to which it is similar. So just keep that in mind as we do this problem. So we're supposed to find the length of UW. So our goal is to find this length right here on the big triangle. If we can get a scale factor going, then this problem will be easy. So look for corresponding sides where you have both values. So 5 and 10 are corresponding sides, the bottom of the green triangle and the bottom of the pink triangle. Okay, if you look at the pink triangle, you can see the scale factor from the green, from small to big, this is doubling. Okay, so we're doing times 2. Here's the scale factor. So if you look for what's going to be corresponding with this large side of the pink triangle, well, that's going to be the 8. Alright, the 8 and the question mark here are corresponding sides. So once again, if we know that it's going to be the same scale factor, then if it was doubling before, it's going to be doubling now. So with that in mind, this must be 16. Okay, so there you go. UW must be 16. Alright, that was pretty easy. Let's see if we can get more of a challenge going. Alright, it's always more interesting if we have to think about it for a little while. We're supposed to find Km. So here's Km right here. So this is what we're trying to find. Maybe I'll put an X on it to remind us that that's what we're looking for. Okay, now things that are similar. So K and O are corresponding. So alright, these go together. L and N are corresponding. So these angles go together. And M and M are corresponding. So these are going to go together. Alright, just keep that in mind. So they're sort of like mirror images of each other, but of course one's bigger than the other. So, one way to do it, since when I look at my corresponding sides, I see 3 and 4, but I don't see a nice, easy scale factor that I can use. It's not just being doubled or tripled or anything like that. So it might be easier if we set up a proportion to solve. Let me show you what I mean. Okay, if we make a statement of proportionality, okay, if we take corresponding sides from the left triangle and make a fraction and put it over corresponding sides from the right triangle, because these are similar, corresponding sides have to be proportional. That means if I make these fractions, they should all be equal. In other words, let's start with the one that we know. Okay, so 3 over 4. Okay, I'm doing left over right. So 3 over 4, that's a pair of corresponding sides. Alright, what else do we know? That should equal, now another pair of corresponding sides, okay, would be the x and the 5. Okay, so that should equal x over 5. Alright, and I could have gone on and made, this would also equal LM. Okay, I'm still doing left over right, so LM over NM. Alright, but as soon as I saw this pair, I'm solving for x. So I could solve this immediately. So I don't need to keep going with my statement of proportionality. Alright, but just notice that if I do the left triangle and the right triangle, any fraction that I make where I make it the same way, left over right, left over right, left over right, those fractions should be equal. That's what it means when we say that the sides are proportional. So let's solve this. Students love to cross multiply, so that means I can make a new equation by doing 4 times x and setting that equal to 3 times 5. So 4x is equal to 15. If I divide both sides by 4 now, that's going to give me what x is. So that's going to give me x is, now this doesn't reduce, so I really could write 15 over 4, and that could be my answer. Okay, or I could put it as a decimal. Okay, as a decimal that would be 3.75. Okay, either way. But sometimes you have a multiple choice test and maybe they'll give you the answer as a fraction, maybe a decimal. So be ready for anything. Okay, how about number 16? So triangle ACD. Alright, let's find it. Well, there's triangle ACD. And that is supposed to be similar to triangle GED. So that's going to be this large triangle up here. Okay, and we're supposed to find DF, which is this right here. Again, let's set up a proportion. So let's start with using a pair of corresponding sides that we know both numbers for. So 3 and 9 are corresponding sides. Okay, so that is actually, we are not going to need a proportion now that I look at it. The reason why I say that is because this is one that we can do in our heads. 3 to 9. What's the scale factor if I look at it that way? Well, this is being multiplied by 3. So it's tripling. So shouldn't it be the same thing if we do the 2? Okay, wouldn't you say? So if we take this 2 and the x, these would be corresponding parts. So if we use that same scale factor and once again multiply by 3, then this should be 6. Okay, so that's the way it is. So DF is going to equal 6. Alright, if it had not been a nice even number, you know, a nice even multiple, then I would have had to set up a proportion. I would have had to go, for example, 3 over 9. Okay, I'm doing small over big, and that should equal 2 over x, again small over big. I could have cross multiplied and got 3x is equal to 18, and then I would have divided by 3, and that would give me that x was equal to 6. Alright, but that would have been the long way in this case. What's next? Number 17. Alright, HIJ is similar to PQR. So it's similar just the way that it looks. Find HJ. So we are looking for this right here. Start with corresponding sides where you know both numbers. So this is not a nice multiple. So I like to use a proportion when I have this type of situation. So if I go left over right, then that's going to be 6 over 4. Okay? Now, here again, okay, corresponding. So if I go left over right again using this pair, then that'll be x over 3. So left over right should equal left over right. 6 over 4 equals x over 3. And you cross multiply. So multiply this diagonal, and it tells us 4x. Set that equal to this diagonal. All right, 6 times 3 is 18. And then you divide. All right, that will reduce. So that's going to give me x is equal to 9 over 2. Okay, I'm just reducing. So that's one form of the answer. As a decimal, 9 divided by 2 is 4.5. So hj should equal 4.5. That's another way to look at it. Okay, just in case anybody doesn't believe me. Okay, all right, moving on. Number 18. Triangle XYZ, okay, x to the y to the z, is similar to triangle ZXW. All right, so we have to be careful here to make sure that we are looking at corresponding sides accurately. So, for example, notice that they say XY. Okay, so here's XY, and that should be similar, or proportional to ZX. Okay, so XY is right here. Okay, I'm going to color it green. All right, so that should be proportional to ZX. Okay, so that should be proportional to this part of the other triangle. So I'm going to color that green as well. Okay, did I miss? Yeah. All right, now let's look at another pair. Let's look at the ending pair. Okay, so let's look at YZ should be proportional to XW. Okay, so YZ is right here. Okay, and we're going to make that pink. And that should be proportional to XW. XW is right here. So we'll make that pink as well. All right, see how these are matching up. Now let's do one more. Okay, we'll go ahead and use blue. All right, the beginning and end, all right, X and Z should be proportional to the beginning and end, ZW. So X and Z on the bigger triangle here would be right here. So I'm going to try to be careful not to cover up what we already have. So X and Z from the bigger triangle would be like this. Okay, and we'll make that blue. Okay, and then that should be proportional to ZW on the other side. So you really have to be careful to make sure you're matching up the correct sides, because this is all twisted around all different kinds of ways. Now with the colors, it's a little bit easier to track. Okay, so let's look at a pair of corresponding sides that we have both numbers for. Okay, so I've got the 1 and the 3. Okay, that's blue and blue for both triangles. Okay, it's blue and blue, so that's going to work for me. Okay, so let's see. I'm going to go big. I'm going to go big to small. So if I make my first fraction of my proportion, that's going to be 3 to 1. Okay, maybe I won't need a proportion. Maybe I won't need a proportion because of that nice scale factor. Okay, I'm going from 1 to 3. Okay, so obviously that's a multiple of 3 as I go from blue to blue. Okay, so let's keep that in mind. So, if I want to find xy, okay, I'm comparing the two greens. Now, as I look at these two greens, suddenly this green 3 becomes the small side as I look at these two. So this, okay, as I look over this away, should get 3 times bigger. All right, as I go from small to big, it's tripling. So if this is 3, then this should be 9. Okay, and that is what's happening. So that's why xy should be 9. Okay, blue to blue, green to green. All right, that was very, very interesting the way they match these up. Feel free to use highlighters or different color pens to help you do the type of thing that I'm doing here. There's no reason why I should have all the fun with the colors. Okay, we're almost done. Better zoom out. Okay, an architect is designing an office building that is to be a width of 50 feet, a length of 50 feet, and a height of 100 feet. So I'm going to need a different color. Okay, so let me zoom back in for a second. So it says 50 by 50 by 100. So the bottom of this thing is a square. So we're talking about 50 by 50 by 100. That's what we're dealing with. What of it? A scale model of the same building is have a width of 18 inches, a length of 18 inches, and a height of 36 inches. Okay? So we're going to make a scale model of this thing. So I don't know. Let me draw another little shape. Alright, well I cheated and I cut and pasted. I'm using my Microsoft Word, but the important thing is so I can get you to understand what's going on. So, to wit. So I'm going to use this picture to be my scale model. So imagine, I mean obviously this is not quite, this should be much bigger. But we'll just use the numbers. Alright, I started to say drawing not to scale, but it's kind of supposed to be to scale. So it's a scale model, so it's hard to use those words in this context without confusing you. Why can I not draw 5 today? I'll give it one more try. So on the real building, let's pretend this is a real building, that this would be 50 feet, okay, and this would be 50 feet, and this would be 100 feet tall. Okay, we better get the units in here because we're about to be mixing feet and inches, so we got to be careful. So 50 feet, 50 feet, and 50 feet. I'm sorry, 100 feet. Meanwhile, our model is going to be 18 inches by 18 inches by 36 inches. Okay. Interesting. So right away, I think we need the same units. I think we'll be in trouble if we have feet on one of them and then we have inches on another. So I think the easiest thing would be to rewrite these in feet. Okay, so you know that 1 foot is equal to 12 inches, right? So for example, if I have 36 inches, if I want to know how many feet that is, if I want to convert that to feet, all I have to do is find out how many times 12 goes into 36. So I do 36 divided by 12, and that'll tell me how many feet this is. So of course, 36 divided by 12 is 3. Okay, I did not type that in right. 36 divided by 12 is 3. Okay, I'm just proving it to you. So that's why 36 inches is the same thing as 3 feet. Now, similarly, if I want to change 18 inches into feet, then I'm going to do 18 divided by 12 as well. Obviously, it doesn't go in evenly. I think it's going to be 1.5. So 18 divided by 12 is 1.5. Okay, that's why this would be the same thing as having 1.5 feet. Okay, it's hard to see over here. 1.5 feet. Okay, so now we have all feet. All right, it's 1.5 feet by 1.5 feet and 3 feet tall. So what do we want to know? Okay, find the scale factor of the office building to the model. Alright, please understand, when they ask for a scale factor, okay, look at the way this sentence is written. They want the scale factor that takes office building numbers and turns them into lengths on the model. So in other words, a scale factor, you can think of it as a multiplier. So we want to find the multiplier that's going to turn the office building lengths into model lengths. So do you think we're looking for a number that's bigger than 1 or smaller than 1? We're definitely looking for a number that's smaller than 1. We're going from the building to the model. So we need to multiply by a scale factor that's very much less than 1. So if we look at corresponding sides, okay, an easy one to use is the height of the model and the height of the real building. So the height of the model is 3 feet. The height of the real building is 100 feet. Okay? So depending on which way we're looking at it, we could be dealing with a scale factor of 3 over 100 or 100 over 3. Okay? If we want the numbers to get smaller, we're going to use this one. If we were wanting the numbers to get bigger, all right, if we were trying to turn the small numbers into big numbers, we would use 100 over 3. All right, but the question wants the scale factor that's going to turn big numbers into small numbers, office building lengths into model lengths. So we're going to use the tiny fraction 3 over 100. So that's going to be the scale factor. Okay, there it is. So let's just keep going. All right, so there's only one more. The entrance into the office building is 8 feet high by 7 feet wide. All right, 8 by 7. Find the height and width of the entrance on the scale model. Round your answer to 1 decimal place. Okay, well, we just found that the scale factor that changes real lengths on the office building into tiny little lengths on the model. 3 1/100ths scale factor. So if we take the 8 and the 7 and multiply by the scale factor, we should get our tiny little model dimensions. So the 8, all right, if we take the 8 and multiply that by 3/100ths, let's see what we get. And if we take the 7 and multiply that by 3/100ths, let's see what we get. Okay, so 8 times 3/100ths, okay, is 6/25. But they said we wanted a decimal, and they really said 1 decimal place, I do believe. So 0.24, I think they want us to round that to just 0.2. Alright, which is approximately equal to 0.2. Okay, and how about 7 times 3/100ths? Okay, that's 0.21. That would also be 0.2, so I'm not really liking that. Okay, let me see what it says. Round your answer to 1 decimal place. Well, it seems silly to round to 1 decimal place, because if I do, that's going to be 0.2 feet both times. Maybe that's the problem. Maybe since we're talking about the scale model, maybe we should go ahead and put this in inches. That's the solution. Alright, so we have 0.24 feet and 0.21 feet. Let's turn this into inches before we round to anything. Alright, so I have 0.24 feet by 0.21 feet. Okay, so how do I change from feet into inches? You multiply by 12. So if I multiply this by 12, then I will have inches. So multiply by 12, multiply by 12. Alright, so 0.24 feet. Might as well do the 0.21 because in here. So I'll just do times 12. So that's 2.52 inches. Alright, rounded to 1 decimal place is 2.5 inches. Okay, so whoops, that's this one down here. 2.5 inches. Okay, now how about 0.24 feet? Alright, 0.24 feet. If I want that in inches, I'll have to multiply that by 12. So that's 2.9 inches. Alright, got to round up. Okay, 2.9 inches. Okay, so those would be the dimensions. 2.9 inches by 2.5 inches. Alright, and that's it. That's going to be the end of this video on similarity and scale factors and similar triangles. I hope it was helpful, and I hope to see you on the next video.